part. Rust. What do you mean by rust? A body is said to be in a state of rest. Its position does not changes with respect to a reference point. And when it comes to motion, a body is said to be in a state of motion. Its positions continuously changes with respect to a reference point. So rest and motion, these are the difference between rest and motion. Once the body started moving from rest, we can say that the body is in motion. So motion can be of different type based on the path. So for example, circular motion is circulatory motion. It's the motion of an object in a circular path. It is called circulatory motion or circular motion. And linear motion. Linear motion is nothing but the motion of an object in a straight line path. And oscillatory motion or vibratory motion, it is the motion of an object, to and fro motion of an object based on origin. For example, simple pendulums or clock pendulum. So these are examples of oscillatory motion. So now we are going to discuss about distance and displacement, but before that we have to check what is the scalar quantity, what is the vector quantity. A quantity is having only magnitude but not direction, it is called a scalar quantity. So for scalar quantities, examples of distance and speed are examples of scalar quantity. So these quantities can be expressed in terms of magnitude alone, no direction. And vector quantity is nothing but the quantities having both magnitude and directions. We can't express these types of quantities without directions. Examples are displacement and velocity. So distance and displacement. What do you mean by distance? Distance is nothing but the actual path traveled by an object from its initial position to the final position is called distance. So the length, actual path or the length. For example, if the body moves from A to B, and if it is 5 kilometers, so this is called the distance traveled by the object from one position to another position. This is called distance. And displacement. Distance is a scalar quantity. So distance can be expressed in terms of magnitude. For example, Ram travels 65 kilometers. There is no direction in which directions, no need of any directions. In which direction he is traveling is not it. So this is called distance. And when it comes to displacement is the shortest length traveled by an object from initial position to some other position for final position. Displacement is a vector quantity, but it needs magnitude and direction. For example, Ram travels 65 kilometers to the west from his house. This is displacement. Displacement can be zero, negative or positive, but distance is always a positive. So we can check what are the difference between distance and displacement. So before that, let us see one diagram. So here you can see body, an object is traveling from, this is the starting point, A is the starting point, so object is traveling from A, and this is a circular motion, so it is coming to A again. So the initial point and final point is the same, and this is a circular path having a radius of R. R is the radius of the circle. So the total distance traveled is 2 pi R. This is the circumference of the circle, 2 pi R. And the total displacement as the initial point and final point is same. So the total displacement will be equal to 0. Right? Okay. So the difference between distance and displacement. Look at that. Distance is the actual path traveled by an object. Actual path traveled by an object. Length of actual path traveled by an object. But shortest length between initial point and far point of an object is called displacement. And distance, as we discussed, distance is a scalar quantity. Vector quantity is the displacement is vector quantity, right? So distance can be positive, it cannot be 0 or negative, but displacement can be positive, negative or 0. And distance can be equal to displacement when it comes to linear path. And displacement can be equal to distance or lesser than distance. So these are the differences between distance and displacement. So we can do one problem here. Look at the question. A boy travels 4 kilometers towards north, then he turns to his right and travels another 4 kilometers before coming to rest. Calculate the total distance traveled, the displacement. So before that, we can draw this one, the general directions. As we know, this is north, this is south, east and west. This is the normal direction diagram, right? Okay, so it is given that always a boy travels 4 kilometers north. So starting point we can always consider this origin, starting point of that point. Suppose it's traveled 4 kilometers north, so we can take this as the starting point. So 4 kilometers, right? 4, and from there he turns to his right and travels another 4 kilometers. Look at that. Right means it will go towards east. So this is his destination. I'm just marking it as D as the destination, and this is the starting point. So now the boy started from S and he reached D, and both the distances are 4 and 4. What is the total distance traveled? The first question answer is total distance traveled is equal to 4 plus 4. That is towards north 4 kilometers, from there right, which up to D it is 4 kilometers. So that is total distance 8 kilometers, right? Okay. Then we have to find out the displacement. Displacement, we know that the shortest distance between the initial point and final point. So here, SD, this distance we have to find out. So look at that, this is a form of a right angle triangle. So for the right angle triangle, we know that the hypotenuse is nothing but the square of adjacent sides square plus opposite side square. This is Pythagoras theorem, right? So root of 4 square plus 4 square is equal to root 16 plus root 16. We will be getting root 32. Right. Root 32 can be written as 4 root 2. How did you get this 4 root 2? Root 32. So you can factorize this 32. You can do 32. This way you can do this is 2 16 4 4. So this 4 can be taken outside the root, and 4 root 2 value, you know, this way if you multiply this 4 into 4 root 2 means nothing but 4 into 1.414, you get 5.65. So the answer is 5.65. 4 root 2 is the displacement. So this is about displacement. Motion can be classified into two: uniform motion and non-uniform motion. Uniform motion, when the body travels equal distances in equal interval of time, so the motion is said to be uniform motion. Equal distances covered in equal interval of time. So that is called uniform motion. For example, if I can discuss like equal distances in equal interval for A, 3 points A, B, C in equal intervals. For example, in 1 hour, the first 1 hour if the body travels 10 kilometers, and the next 1 hour also body travels 10 kilometers. So the body travels equal distances in equal interval of time. The motion is said to be uniform motion, right? Okay. And non-uniform motion, in this type of motion, the body will travel unequal distances in equal interval of time. That is called non-uniform motions. So, two types of non-uniform motions are there: accelerated motion and decelerated motion, deaccelerated motion. So, accelerated motion, when the motion of the body increases with respect to the time. Motion increases with respect to time. As the time increases, motion also increases. This is called accelerated motion. But when it comes to deaccelerated motion, this is also called as decelerated motion. The motion of the body decreases with time. So this is what is called decelerated motion. So I hope you understood this topic.